So based on the curveness of the shape of the teeth, okay, so the two types of teeth can be seen, that is one is cycloidal type and one is involute type. Okay, so this gears actually according to the different manufacture of this gears, and it is actually very costly to manufacture the gears, and always you know that gears will go under a lot of wear and tear, because every time there is going to, each and every teeth is going to have the meshing, and always there will be contact. So whenever there are two surfaces are in contact, automatically you know that lot of friction is going to be generated there. So always the wearing will be very high, and also the cost of the gears are always high, because even the manufacturing of the gears are little bit complex, and also you can see that the material should also be very used that is very of very high strength. Otherwise what will happen, after only for some working duration of around 10-15 minutes it may collapse there. So the teeth should be very strong enough, and for that different standardized gear teeth are preferred. Okay, so based on that common forms of teeth are cycloidal profile teeth and the involute profile teeth. Okay, so that we'll see now. So in cycloidal profile teeth, what will happen, the faces of the teeth are epicycloidal, or the flanks are like of hypocycloids. And if you want to understand the definition of cycloid, so cycloid is nothing but the locus of the point on the circumference of the circle that rolls without slipping on the fixed straight line. Okay, so we'll show you the figure, you can see. So one you can see, one is a epicycloid and one is a hypocycloid in that. Okay, so an epicycloid is the locus of a point on the circumference of a circle that rolls without slipping on the circumference of another circle. So you can see here what will happen here on the, you can see the teeth here, the face part is seen here, the way flank is coming. So from there you can see there is a locus of a point from there on the circumference of the circle, and from there what will happen, the circle is going to roll without slipping on the circumference of the another circle. So you can see a roller is there here, and if you get a path of curve like this on this rolling, so this is a type of epicycloid. Okay, and similarly hypocycloid is the locus of the point on the circumference of a circle that rolls without slipping inside the circumference of another circle. So here this is outside, and here you can see the hypocycloid, so that is the inside part. So that is going to have the meshing that will be having without slipping inside the circumference of another circle. So you can see the figure. So the arc which is maintained here on this circle, this is outer part from the teeth profile. So same way you can see hypocycloid, it is having the internal part. Okay, so the locus, if it is formed like this in the cycloidal format, so this is known as about the cycloidal profile teeth. Next we see about the involute profile teeth. You can see the teeth again here. So what is happening here in involute type of things, the locus of the point on a straight line which rolls without slipping on the circumference of a circle, but here what will happen, it is the path that traced out of by the end of the piece cord being unwound from the circumference of the circle. So for example, if you want to open any of the rolling sheet or any type of thing, when you open it, what will give, you unwound it. So same way, if the path is being opened in this format, where your entire contour that is going to plot over here, you can see the profile here A to F teeth, and if you take the pitch circle from here, and if you take an entire arc like this, that is from A to B, then B to C, like this arc can be seen here. So it will open like that. Okay, so the circle on which the straight line rolls, or from which the cord is going to unwound on, that is known as nothing but a base circle. So this type of profile, what we will be getting is about the involute profile. So there entirely the arc will be traced in such a way that it will open it in the form of a roll sheet. If you take a paper and roll it, and when you open, what will happen? You will get the entire path, entire curve there. So same way here also, if the path is to be traced on that teeth, on that profile, and the same thing is going to be generated throughout the arc. So that is from A to F, whatever is there. So in the same contour, you can get the path from A to B, then upward to C. Okay, and that should be taken from the base circle. Okay, so this is about the involute profile teeth. Okay, so we'll not much concentrate on the type of different types of profile teeth. That we will again discuss it later when we go further part. Okay, so first let us understand now how to calculate the length of path of contact for a two gears in a mesh. So this is very important, and this is very important derivation, and also every problem we are going to solve will be dependent on this. Okay, so each and every question when you solve, your length of path of contact is very important there. You have to find out this. Okay, so first let us understand the concept based on this. So here two gears are in a mesh, where you can see the first part, lower bottom, that is about the pinion, that is on the lower side, and on the top side you can see the wheel. Okay, and at the extreme points you can see the center of the two gears which are being shown there, that is from O1, and then at the top side O2. Okay, so the pinion, from there you can see the rotation is in the form of clockwise direction, whereas the wheel which is shown there above, that is in the opposite direction, that is counterclockwise direction. Okay, and when the meshing takes place, you can see it is, which is shown by the pink color. So pink color will be nothing but the point where the both from the pinion as well as from the wheel, the intersection will take place. You can see if the pink color from here and from here, also from here, that will be nothing but the pitch circle, pink color which is shown here. Okay, that is nothing but the pitch circle. So from there only the pitch circle, at that point intersection of this pink color, there only the exact meshing point will be taking place. Okay, so first let us understand the total dimensions which are shown here. So the small r is nothing but the radius of the pitch circle, that is for the pinion. You can see here small r is being shown here at the bottom side. You can see the radius of this pitch circle is given as small r. Okay, and then radius for the addendum, that is given as RA. Okay, small r A. So that is the from O1 to the outer part, that is on the addendum circle. So you know that addendum circle is the farthest point from the center. So this arc. So this is the addendum circle, and the distance measured from O1 to this addendum circle, you will be getting the addendum circle here, and this, sorry, you get the addendum distance, that is RA. Similarly, now on the wheel side, capital R is being considered radius of the pitch circle. The radius of the pitch circle we taken it as R, capital R. And again capital RA, we take it is the radius of the addendum again for the wheel here. Okay, so the top side on this part and from this also, both are nothing but addendum circles which is shown here. Okay, so this is all we have taken small r for the pinion and the capital R for the wheel. Okay, now comes the intersection part. So what will happen, we just see the path here. So when the this meshing take place, there may be some distance which has to be in contact. So the path of contact is nothing but the length where the entire meshing will of that one teeth is going to take place, and at what distance, what length the total mesh will be in contact. So that you need to measure here. Okay, so first let us understand the points which are being shown there. So first is about here from the distance contact, it is from K. Okay, so you can see this is K on this part. Then if you take a line here, this is again a path of our point P. Then you can see the point L here, and the perpendicular distance drawn from here O1 you get a M here, and from O2 you get N here. Okay, and then this is the point which is getting the arc here, that is point G, and here the point you taken as point H. Okay, so mainly you have to concentrate now the distance how the meshing is going to have in contact. Okay, that we'll see now. Okay, so the angle for the both the turn, that is angle phi here for both the consideration, they are taken for angle phi. Okay, now we'll see how to solve this. So first what I told now, RA we take it as a radius of addendum circle of the pinion, and capital RA we take it as a radius of the addendum circle of the wheel, and small r we take radius of pitch circle of the pinion, and capital R we take radius of the pitch circle of the wheel. So these are the assumptions what you have taken. Now from the figure you can see O1M is equal to O1P cos phi. So you take it as first O1M. Okay, so O1M you can see it is the thing but the line drawn here, perpendicular line on this path, on this straight line. If you draw a perpendicular from O1 to M, that is nothing but a perpendicular. You can see that it is shown as perpendicular. Similarly here also from O2 to N, that is also taken as perpendicular. So if you want to get O1M, so O1M is nothing but O1P cos phi. So it is nothing but O1P cos phi, because the angle turned here is phi. So at this point, the point of intersection where it takes place, it is the point P now. So it will be O1P cos phi, the angle turned here. So it is nothing but O1P what you have taken, it is nothing but the radius. Okay, you know that it is nothing but the radius on the pitch circle. So it is nothing but small r. So entire radius will be nothing but same. So small r. So it is nothing but r cos phi. Similarly, the radius of the base circle of the wheel is O2n. So O2n is nothing but O2p cos phi. So here from the top side, O2n here, so it is nothing but O2p cos phi. So always we consider here P is the common point for both the consideration. So there the calculation becomes very simple if the common point is taken. Okay, so P is exactly at the intersection of this for both the gears. Okay, next, so similarly you get now r cos phi and then capital R cos phi. Now from the right angle triangle O to Kn, so this triangle O to Kn, so in this triangle using the trigonometry ratio, you know that hypotenuse square is equal to nothing but the other two sides square. So this is the right angle triangle, so this is the hypotenuse O2 here, from O2 to K here, and then this again Kn, it will be again one opposite side. So O2K square will be equal to O2N square then plus Kn square, right. So from there we take it as Kn is nothing but equal to root of O2K square minus O2N square. So what is O2K? It is nothing but the distance of the radius of the addendum circle, so that is RA, and O2N square, so just now you just from the base circle you just determine this O2N, so O2N is r cos phi, so substitute that now, so you get r square cos square phi, So substituting this, you will get a root of RA square minus R square cos square phi. Okay. Next, Pn. Okay. So this point from here to here, now this will consider P to N. So what will be getting Pn? Pn will be O2P sin phi. Okay, O2P sin phi. So that O2P is nothing but capital R. O2P is nothing but capital R, because this is the radius now. Capital R. Then you get R sin phi. So now the length of part of the path of contact or the path of approach, that is Kp. Kp will be nothing but Kn minus Pn. Kn minus Pn. You want to first find out the distance from K to P here. Okay. So this is nothing but Kn minus Pn. So you first calculated now Kn also, then Pn also. So let us substitute now. So Kn, this term Ra square minus R square cos square phi, this one, minus Pn, this is R sin phi. Okay. So what will be getting here? So Kp will be equal to this term. Okay. Now similarly, the right angle triangle for O1ML, that will from the bottom side we will see now. Okay. So what is the ML here? So this distance now we will take it from the same from the bottom side. So you know that if you want to get from this length M to L, so this is one side and this OM is the perpendicular distance. So this is the hypotenuse, that is O1 to L. So this is hypotenuse. So hypotenuse square, again this square plus this square, that can be considered for this triangle. So let us see now. So ML is equal to root of O1L square minus O1M whole square. So again substituting the values what you obtained for O1L and then O1M. So this is Ra square minus R square cos square phi, same as the previous thing what we have taken, capital R. So now we are taking for a small r from the lower side. So similarly MP also becomes O1P sin phi, MP downward side, this one, MP this distance. So MP becomes O1P cos sin phi, that will become R sin phi. And therefore the length of path of contact, again for this is known as the path of recess. So that will be PL equal to ML minus MP. So this same way from the top side what you have taken, say it is ML minus MP. So this distance can be considered from here, ML minus MP. So you get this remaining distance. Okay. So from there you can get the remaining part PL equal to ML minus MP. So substitute again this, you will be getting same type of equation, but all will small letters, small r. Okay. So finally the length of path of contact will be this addition of path of approach and path of recess, that is Kp plus PL, that is total length of KL. Okay. So addition of both the things, you will be getting this term, entire term. So this is the length of path of contact. Okay. So finally what we need is K to L, that is the path of contact. Okay. So you can see from this distance to this distance, this is known as the path of approach. This is known as path of approach, and from this distance up to here, this is known as path of recess. Okay. And the total length So that is known as path of contact. So total length. Okay. So whenever two gears are in mesh, what will happen? The total length which is taken from once when the mesh takes place to this length. So this is the total length. This is the path of contact for this. And we have first using this triangle, we have first solved for the path of approach. So here we got all with respect to capital R, and for path of recess we have taken the lower pinion part, and from this triangle we got the small r values. So it is only with respect to radius what we need to understand now. So one is the this r, the RA, and here this RA and this R. So only you have to understand with respect to these terms. So when you solve the problems also, when you want to calculate the length of path of contact, so you should know these things, then you can calculate the path of contact and along with the angle. So these things should be known to you. Okay. So when you solve the problems, so first is nothing but you should know the value of the radius. So you can see only all the radius are there, and nothing but the next phi, the angle phi. So phi terms you should know to get the path of contact. Okay. So all problems you need to first calculate the path of contact only. So the length of path of contact is this. Now after this calculation of length of path of contact, next we'll go with the arc of contact. So length of path of contact will be straight line, but it is measured, and arc of contact is on nothing but the arc on which it is being measured. So same way, now this is the total length. So if you measure this on the arc, so because it is having the arc, because this is a type of circle on that segment if you are taking, so if you measure the arc, that becomes the arc of contact. So if you take a straight line, it is nothing but length of path of contact for this, and if you take on the arc side, it becomes the arc of contact. Okay. So like this the things can be done. So first what you do, you try to draw this figure correctly. I will give you time. So this figure is very important, because for all problems you are going to use this term. Okay. So you draw this figure, you need this figure, and even the derivations what we did now, that is also frequently asked in the exam. Okay. So this is very important derivation for as far as gears chapter is considered. So draw this figure correctly, and using the trigonometry ratio you first try to calculate this. I will wait, but you do it correctly, because now again we have one more class, so there I will solve the problems based on this now. Okay. So first you should know what is the radius for R and RA and all. Okay. Then you can solve the problems easily. Okay. So take down this figure and also the equation what I am going to tell you in the derivation now.